Good morning, Cappuccino. We are continuing with binomial distribution probabilities, and today we're going to be looking at cumulative binomial probabilities. So the last problem in the math space assignment from yesterday had this problem. You might have had slightly different numbers in yours, but it was the same basic problem, where we had a toy frog jumps over 80 centimeters 76% of the time. If the frog jumps 7 times in a row, what is the probability that at least 5 hops are over 80 centimeters? So this is a cumulative binomial probability because you're looking for more than one value. It says at least 5 hops are over 80 centimeters. So cumulative is, we're going to use this method on our calculator. We're going to use this method when we have words like more than, at least, no more than, okay, all these things that imply, etc. All these things that imply a range of numbers, okay? So if I were to write this out, what is it asking me to find? It's asking me to find the probability that the frog is successful at jumping at least 5 times. That means 5, 6, or 7. At least 5, so it includes the 5, so I know it's going to be equal to 5. And if it's at least, then I know it's going to be the numbers that are bigger than 5, because 5 is going to be the smallest. So I'm looking for that it is greater than or equal to 5. The probability that the frog is successful greater than or equal to 5 times. Okay? So this is how I can write the question. Now, I could do this by just finding the probability of each piece individually. Okay, so I could say this is going to be the same as doing the probability of x equals 5 plus the probability of x equals 6 plus the probability of x equals 7, because there's a total of 7 jumps. So let's go ahead and we'll do that on the calculator. It's good to review. So let me get out of what I was doing. Okay, so we're going to review this. So to get each one of these, we're going to do them one at a time. We're going to do second vars, which gets me my distribution functions. And I'm going to go down to A, option A, there it is. And I'm going to put in my number of trials is 7. My probability of success is 0.76. And my x value for the first one is going to be 5. And hit enter, enter. By the way, I did look up how to do this on the TI-83. On the TI-83, you would just get this on your screen. And you would put in the number of trials, comma, the probability, comma, and then how many you want to get correct, comma. Okay, so if you were doing this on the TI-83, you just need to take these 3 numbers and put them in. The n, okay, so this is the n, number of trials. The probability, right here, that would go next, so it would be the p. And then the x value, that would be this. Okay, so if you were doing this on the TI-83, let's see, where should I put this? Let's go back a page. So on the TI-83, here it is. The TI-83, if you have a TI-83, you would do this also, second vars A, but when you got here, you would have, it would give you this, and then you would have to type in your number for n, your number for p, and then your number for x. These 3 numbers separated by commas. Okay, so those of you who have the TI-83, that's all you have to do to make it happen. All right, back to our problem. Okay, so I put in my numbers, and I got for the probability of it doing it 5 times is 0.307. By the way, I'm going to keep all the digits in my calculator because I'm going to add them at the end. I just realized I probably should have pulled the curtains here at my house. I'm getting kind of funky glare. So let's go ahead and pull the shade so I get less glare on this situation. Sorry, I should have set up a little bit earlier. Go ahead and try the next one without me. See if you can get it before I do. I'll try and get some of the shadows. There we go. That looks better. Okay, so the next one, second vars, scroll down to A again. I can jump there also by doing alpha A, and it gets me right there. Okay, so I already have the 7 in, the 7, 6, and now I'm going to do x value of 6. Enter, 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 and that gets me 0.324, and then I'll do it again. Second vars, I can jump to A and change that to a 7, and I get 0.146. All right, so then if I add those all together, okay, the probability that the jumps are at least 5 is going to be it's going to be equal to, if I add those together, plus, add them together, I get 0.777 if I'm doing 3 significant figures. So 0.777. Okay, so that's one way of doing it, but there is a slightly more efficient way of doing it. I won't say it's like a whole lot more efficient, but there is another way of doing it. So there is another option here on the calculator for cumulative probabilities, and it's in the same place that we had it on here, but there's one kind of problem with it. Okay, so if we want to do this on the calculator, we're going to use the cumulative function. So cumulative function, and the cumulative function, if I bring that up, it basically is right underneath. Basically, it is. It's right underneath the other one. So if we go down, instead of stopping at A, we're going to go to B. Where is it? There it is. So it's this one right here. So we would do, again, we would do second vars. And this time you would go to option B, which is B binomial cumulative distribution function. Okay, so cumulative, and we would select that. And you'll notice it looks exactly the same. It says trials, and it says P, and it says X value. Okay, so this is where things get confusing. You're like, X value, but I want to use an inequality. And if you notice, there's no inequality symbols on my calculator. So you're like, huh, what do I do? Okay, so for this particular one, our trials is going to be 7. Our probability is still 0.76. But now for our X value, this is the weird part, where you have to put in 4. We're going to put in the number below 5. We're going to put in number 4 because the calculator, all it can do when you do this cumulative thing, all that it can do is find a less than function. So when you use this, it can't do a greater than function. It can only do a less than function. So this guy here is a little bit limited. Okay, the calculator can only do, I'm going to write this down, calculator can only find the probabilities of X that are less than or equal to X. So when you put in your X value here, it actually, you can't put in the 5 and get greater than 5. You can only get less than something. Okay, so if we want a greater than function, what we're going to need to do is we're going to have to get this answer and subtract it from 1. Okay, so the calculator can only do this. So for our particular situation, if I were to graph a number line, if I wanted the values that are at least 5, okay, so the frog could do 0, 1, 2, 3, 4, 5, 6, or 7, right? So if I want at least 5, I'm talking about I want 5, 6, and 7. But the calculator can only do less than or equal to. So I don't want these ones. I don't want 4, 3, 2, 1, 0, but that's all that the calculator can tell me. So the calculator is going to figure out these. It will not figure out greater than ones. Okay, so that means all of these added together is going to be 1. Okay, so the probabilities of 4 and less than plus 5 and greater than would give me all of my probabilities, so those have to add up to 1. So what we're going to do is we're going to do 1 minus the probability of x is less than or equal to, notice here's my 5, this is my 5, this is 4, so I'm going to have to tell it to start on 4 because it's going to give me from here on down, and then we're going to subtract that from 1. Okay, so if I put that in, that would be x minus 1. That's going to give me what I want, which is the probability of x is greater than or equal to x. Oops, I made that a little squishy. I should write that better. Okay, so I put this into my calculator. My trials is 7. My probability is 0.76, and my x value is going to be 4. And so since I'm doing a cumulative probability, it's going to give me all the probabilities up to and including the value 4. So if I do that, and I get my answer, I get 0.223. Okay, so this gives me the probability of x that's less than or equal to 4 is equal to 0.223. But I want the probability that it's greater than or equal to 5, so I'm going to take that 1 and I'm going to subtract this number. I'm going to subtract my probability of x that's less than or equal to 4, and when I do that, 1 minus, I'll select that value, hit equals, I get 0.777, which is what I got when I did the whole thing by hand. So I get 0.777. So the probability that the frog will jump at least 5 hops that are over 80 centimeters is going to be equal to 0.777. Okay, so the thing about these cumulative probabilities is you have to be really careful about where is your dividing point. Okay, we wanted at least 5, so that includes the 5. So you really got to think about which values are going to work for you. So 5, 6, and 7 works for me, but I can't directly find that because the calculator can only do less than. It can only do less than and equal to. When you put in your x value, it's going to do a less than or equal to. So you got to really think about how are you going to set this up, and then how are you going to get the difference. Okay, so other examples would be, what if you wanted it between two values? So what if I was interested in the frog jumping between 2 hops and 5 hops? Okay, so it can give you 2 and below, and it can give you 5 and below, but then you would have to subtract those answers to get the number that is between. Okay, so I'm going to set up some problems in MathSpace where you have to think. You're going to have to think about it. Think about the words that they give you. Maybe set up a number line to try and figure out where's your dividing point, because remember, the calculator can only do less than or equal to. All right? So when in doubt, just set it up with the individual probabilities and add them together. But if it's a lot, if it ends up being a lot of individual probabilities, you really do want to try and figure out where's your dividing point, what's the calculator going to give you, and how can you use subtraction to get you the answer that you want. All right, good luck.